All right, IM1 classes. Today we're talking about the Pythagorean Theorem. You may have heard about the Pythagorean Theorem before. May be familiar with it. It's a squared plus b squared is equal to c squared. And you may have actually used it before, but we're going to go over what all this stuff means. So first of all, Pythagorean Theorem in words. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the hypotenuse. To understand what all this means, we need to know some things about right triangles. First of all, Pythagorean theorem works only for right triangles. That's what we're going to be doing today. You use the Pythagorean theorem to find the missing side lengths of a right triangle. A right triangle is a triangle that has a right angle. All right, so a right angle is just a 90-degree angle. It's like the corner of a square. All right, so this is the right angle. The other words in here, so it said the squares of the legs. So the legs are the two shorter sides. Rather, I should talk about the hypotenuse first. The hypotenuse is the longest side of a right triangle. It's always going to be across from the right angle. So the longest side, we call that the hypotenuse. The two sides of the triangle that are not the hypotenuse are the legs. All right, so as we say in the first slide, the Pythagorean theorem is a squared plus b squared is equal to c squared. All right. With this, you want to label the side lengths. So this is A, B, and C are the side lengths of the right triangle. What you need to remember is the hypotenuse is always C. All right. The legs then would be A and B. These are interchangeable. This leg could be A, this leg could be B. It doesn't matter. What matters though is that C is the hypotenuse. It's always the longest side of the triangle. All right. And so where this comes from is you square these two sides, add them together, it's going to be equal to the square of this one. So let's look at an example. Find the missing side lengths. Write your answer in simplified radical form. So that's we've practiced simplifying radicals here. So first thing I'm going to do is label the sides A, B, and C. So C is always the longest side. So this side here. And then A and B, this is interchangeable. Doesn't matter which one you put as which. All right, so the Pythagorean theorem helps to write it out. A squared plus B squared is equal to C squared. Fill in the values here. So A is 8. B is 6. And C is what we're trying to find. So I'm going to put in x squared there. Square these values. 8 squared is 64. 6 squared is 36. 64 plus 36 is 100. And now from here, to finish solving for x, you need to take the square root of both sides. The opposite of squaring the variable here is square rooting. So on this side, the square and the square root cancel out. So all you have is x. Square root of 100 is 10. So the missing side length is 10. All right. Let's look at another example. So same thing, I'm going to start off by labeling the side lengths. So label the hypotenuse first. The longest side is C. The other two sides, A and B, are interchangeable. So it's going to be A squared plus B squared is equal to C squared. A is 5. B is 10. C is x squared. There we go. So 5 squared is 25. 10 squared is 100. 25 plus 100 is 125. Square root both sides to solve. 125 is not a perfect square, so I need to do a buddy system on that one. I need to put this in simplified radical form. So 125, I'm going to do a factor tree. It ends in a 5, so I know I can divide that by 5. So 125 splits into 5 times 25. Then 25 is 5 times 5. So over here, I'm going to work it all out over here so that square root and that squared cancel out. This would be square root of 5 times 5 times 5. So remember, you look for pairs. For every pair, one goes on the outside, cross it out. And so the simplified radical form is 5 square root of 5. So we just did 2 examples where the missing side length is the hypotenuse. So let's look at an example where the missing side length is not the hypotenuse. All right. So starting with this one again, label the sides. So the longest side is C. So always label the hypotenuse first. And then A and B doesn't matter, interchangeable. You can use the Pythagorean theorem to find that missing side. So we have A squared plus B squared is equal to C squared. A is X, B is 5, C is 13. So X squared, we get, just leave it as X squared, plus 5 squared is 25, is equal to 13 squared, that is 169. I'm going to put in a line of separation because there's a little bit more to solving this one. So I want to get X by itself, so I need to eliminate the 25 from that side. So I have to subtract 25 from both sides here. So I get X squared is equal to 169 minus 25 is 144. Now when you just have the squared, I'm going to square root both sides. This comes out to square root of X squared, that's just X. Square root of 144 is 12. So the missing side length is 12. All right. One last example. So same thing, we are missing side length. So I'm going to start off labeling the side. So the longest side across from the right angle, this is the long side, so this is C. A and B doesn't matter. Put A, these are interchangeable. I'll put it in like that. So it'll be A squared plus B squared is equal to C squared. A is X squared plus B is 5, so squared. C is 6 squared. So X squared plus 5 squared is 25. 6 squared is 36. Again, I'll put in a line of separation here just because there's a little bit more to solving. So I need to eliminate the 25. So plus 25 minus 25 cancels out here. I get X squared is equal to 25, or 36 minus 25 is 11. Solve for, oh, I want that in green. Square root both sides. X squared, square root of X squared is just X. And so from here, square root of 11, that is not a perfect square, so we need to do a buddy system on it. 11 doesn't split into anything. It's a prime number. So when that happens, you just leave that 11 underneath the radical. So it's just square root of 11. So if there's no buddies, nothing to pull out, you just leave it as is, and we are done. All right. If you have any questions, just email me. Other than that, that's all I have for you guys. So we'll see you next time.